One thing that I didn't mention is that I'm a mechanical engineer, as is Terry. And as a mechanical engineer, what you're about to see, I think, is the absolute coolest place in this entire facility, maybe entire company. You've seen some really cool stuff, but there's some really fun toys in here for a mechanical engineer. It is a model shop. There's a lot of machine tools and things like that. We've done our best to clean it up, but it is what it is, and so there's things that can bump you in the thigh and give you a bruise, or you know, things like that. So just be mindful that it is a model shop. Come on in. So as I said, this is the playground for our engineers. So as they come up with ideas or innovations, they come down here to the model shop and they work with these. We have two master machinists in here that profess to being able to build anything and break anything. And so they come down, the engineers come down here with their designs, and then they get a lesson in reality. The reality in terms of how to build things cost effectively, how to build things for reliability, for manufacturability, and so forth. But here the model makers iterate with the engineers to tune the designs so they ultimately perform the best, are the cheapest to build, and helps us get to market the quickest. An example, in the Z Workstation, back when we were initially designing this and worrying about the airflow, and as Terry talked about earlier, everything was engineered. Everything in there has a purpose. Well, the mechanical engineers were designing and tuning the airflow baffles. This piece that slides in here, and this is a piece that was produced here in the model shop concurrently with the tooling that was being produced on the other side of the world. And so the engineers were able to tweak and tune their designs daily and stay just a little ahead of the tooling process, such that we ultimately came up with a finely tuned design that not only gave us the cooling properties that we needed, which affects reliability and performance, but it also gave us the acoustic qualities that we needed. The tools that we use in order to do this, and this is a great cue, you're looking at one of them right here, is this is what we call a 3D plotter. It's a tool used in rapid prototyping. This is a laydown 3D plotter. We have a build-up 3D plotter back in the room here. It's called stereolithography. Stereolithography is basically a vat of resin, and then you use a laser to trace out the elements of the design. So this was done actually on the SLA machine. The cool thing about the rapid prototyping and the materials that we have, this is ABS plastic, and then the resin, we could buy different resins for the stereolithography. You can actually do physical property testing with this when it comes off the SLA. So the snap details and things like this. So not only do you get a visual representation of how things work and a functional representation of how it's moving the air around, but you can also test the strength of the snap details, whether they're going to work, whether they're going to hold it in place, send it into the shake and shock. Let's see. I think you want to see things broken today, is what you said last night, right? Yeah. So shake and shock will be one of your next stops.
Can I press the button?
He wants to press the button. There you go.
Oh, okay.
Yeah. I asked him what his only requirement, what he was looking forward to the most on this. He said, I want to break something. I want to push the green button.
Okay.
So I'll pass this around because there are some different properties as a product comes off of this machine versus the SLA. You can see the fine detail in this one versus this one. This is ABS plastic, and this is the SLA resin. As that's going around on the front side of the design process, sometimes you have something physical that you want to create a CAD representation of. And so we have a 3D scanner over here, and this is an example of a part that was scanned on the 3D scanner, and this is the part that was produced on that machine after it was scanned, so it was reproduced. It's a 3D part, but because this is coming into a CAD drawing, once you have the outside parameters and profile, then you can do anything to it. You can manipulate it just like you would if you were designing the part from scratch. Questions? I can talk all day about what we're doing here. So
You remember I talked about this. So, incredibly complex plastic part that we could build here because we have the tooling capability. The engineers sent over the CAD drawing, and the model guys here, the SLA is in that room right there, basically cranked out this part, and we could begin to test immediately. Why is it important? Again, time to market, but also think about cost. The fact that if we can get ahead of the tooling and not have to go through multiple iterations on tooling, we can also reduce cost in what it takes us to design the product, which we ultimately translate back to our customers in terms of what we deliver to the marketplace. So incredible advantage to have this kind of stuff. The engineers just love to have. It's like, yeah, I can check things out. I can check to see if the cooling and the airflow works correctly before I ever get a part from either software or hardware.
one other thing I'm going to talk about as we're kind of walking our way this direction, but another advantage of the model shop is not only can the engineers work and tune their designs for optimal performance, we can also produce photo quality parts. So in parallel with the finishing up the product, we can actually start going to and producing the marketing materials. And so this is an example of what a final part would look like. It was produced here in the model shop on the SLA machine. And then the master model makers over here figure out a way to paint it. They first painted it black, then they painted it silver, and then they laid it down on a neat little machine you're going to see in a second, laser engraver, and they etched off the silver paint to where you can see the graphics on here. So this is actually a removal process as opposed to like a silk screening type process. But this part went from here to some photo shoot somewhere as they were building up the marketing materials. So let's come over and take a look at the laser engraver. Instead of having a print head or an inkjet head, it's got a laser on it. And he's got a photograph on his screen here, and it's been downloaded to the printer, the laser engraver. And this is being engraved on hard anodized aluminum. You could do it on just regular aluminum, but the contrast isn't very good. So that's why we chose to do it on hard anodized aluminum. And you can kind of see the sparking going on as it's engraving. And to that end, we actually have a gift for you from the model shop as we leave. We have, to commemorate the day here with the Workstation Lab, we have a card holder for you. Any questions? Well, you're an easy crowd. Thank you very much.
Thank you.
We're going to go out this door here.
This is